At this point, you might be wondering, how do machines learn? Or what exactly are they learning? Is it the same as how humans learn? As educators, you might also be curious about how computer scientists train these systems. I will do my best to explain it in a way that is easy to understand. Let me use a very simple machine learning algorithm called linear regression to explain what machines really learn. No worries, there won't be any mathematical equations. Imagine you are the machine, and you are presented with a list of people and two things you know about them: their years of experience and their salary. Let's say you have 5,000 data points like this. We would like the machine to learn a simple relationship between years of experience and salary. Well, by staring at the dataset, their relationship is not very obvious. So let's visualize that. Here is a visualization of the dataset. Each blue dot represents a person's salary based on their years of experience. As a human, you can easily see that, in general, more experience tends to lead to a higher salary. The two things have a linear relationship. But the machine doesn't know that, and it's trying to figure out how years of experience are related to salary. At the start, the machine has no clue, so it makes a wild guess, shown by this red line. It randomly thinks this is the relationship between experience and salary. But as you can see, it is not even close. It needs to learn. Here is where the magic happens. The machine starts learning by adjusting its guess. With each adjustment or iteration, it compares the red line to the actual data. By the way, we call the actual data the training dataset, the blue dots, and asks itself, how am I doing? How can I make my line fit the data better? Oh, I should rotate the line counterclockwise, change its slope, and move it down. If you know a little algebra, a line is controlled by two parameters: slope, which is W, and intercept, which is B. As you can see, they're changing all the time. And they're moving towards to the right answer, 5,000 and 30,000, right? So it does this again and again, adjusting the line little by little. Each time, it reduces the gap between the predicted salary, the red line, and the actual salary, the blue dots. After a lot of adjustments, the machine settles on the best fit line. This red line represents the machine's final understanding of the relationship between years of experience and salary. It's not perfect, but it is useful. Then how do I use this trained model? Now, when it sees someone with a certain number of years of experience, it can predict their salary based on what it has learned from the existing training data. So what did this machine really learn? It learned the general trend or relationship between two things: how much a person's salary increases with every year of experience. That's the slope, W. What the starting salary is for someone with 0 years of experience. That is the intercept, B. This is a basic but powerful idea in machine learning, where the goal is to uncover patterns in data. It starts off with a rough guess, learns from its mistakes, and improves its predictions step by step. We've already seen how a machine can learn the relationship between years of experience and salary. But in reality, salary is influenced by many factors, not just experience. For example, someone with a higher education level, like a master's degree or a PhD degree, may earn even more if they have the same years of experience as someone else. So next, let's take a look at a more complex dataset. There, we're adding education level as a second factor. So for each person, we know their years of experience, just like this one, their education level. There are 3 levels: bachelor's, master's, or PhD. And the outcome is their salary. So let me show you a visualization of this dataset. Okay, so here is years of experience. Here is education level. And this dimension is the salary. And we have those data points in this 3D space. Now let me rotate this 3D plot so you can get an intuition of how this dataset looks like. As a human, it is quite obvious that maybe we can fit a plane that cross all those data points. Let's go back to the slides. Just like before, the machine starts off with a completely random guess. But instead of just drawing a line, it now guesses a plane because there are two factors it's trying to understand: years of experience and education level. This random plane is the machine's first attempt at connecting the dots between experience, education, and salary. But as we can see, this initial guess is way off. Now let's watch how the machine learns. As you can see, it will adjust its guesses, this time by moving and tilting the plane until it better fits all the training data, the blue dots. With each adjustment, it checks how well its current plane fits the actual data and then makes corrections. It slowly starts to learn how both experience and education affect salary. Just as before, after many adjustments or iterations, the machine finds the plane that best fits the data. Again, it is not perfect, but it is useful. Now it understands the combined effect of years of experience and education level on salary. So what did this machine learn this time? It learned the combined effects of two factors: how much salary increase with each additional year of experience, and how salary also increase depending on the level of education. By understanding both factors, the machine can now predict salary more accurately than if it had only looked at experience alone. So this is an example of how machines can learn from multiple variables at once. In this case, the machine didn't just learn one relationship, it learned how two variables work together to affect salary. This idea, learning from multiple factors, is a key concept in machine learning. It helps machine make better, more accurate predictions, just like humans consider multiple factors when making decisions. If you miss an important factor, then you may make the wrong decision, right? Now, let's think bigger. Imagine we add even more factors or features. Maybe we can add a person's location or their industry and more. With each new factor or feature, the machine needs to learn a new relationship. And with each relationship, we introduce more parameters for the machine to learn. In this case, the machine is no longer just drawing a line or a plane. It's fitting a higher dimensional model, and it is learning many parameters, one for each factor or feature. Unfortunately, we can no longer visualize that high dimensional space. Use your imagination. Now, let's make a leap from salary prediction to something much more complex: language. A model like ChatGPT works in a similar way, but instead of predicting salary, it is trying to predict the next word in a sentence. Just like our linear regression model learns parameters for years of experience, education, and other factors, large language models are learning relationships between words. But here is the difference. Instead of just a few parameters, a large language model, for example, an early version of ChatGPT, has to learn 175 billion parameters. That explains the first L in large language model, that is, large. Why does ChatGPT need 175 billion parameters? It's because language is incredibly complex. Think about all the nuances in language. For example, the same word can have different meanings depending on context. Different sentence structures convey different emotions or intents. Idioms, sarcasm, and tone all require understanding beyond just word definitions. To learn all these relationships and nuances, the machine needs a vast number of parameters. Each parameter helps the model get better at understanding and predicting language. So you can roughly think of each parameter as a brain cell. That's not accurate, but is a good analogy. So here's a general rule of thumb. The more parameters a model has, the more intelligent it might be. Of course, the more expensive the training will be. Then what about the training data? ChatGPT learns from a massive text dataset scraped from the internet. For example, it learns from Wikipedia articles, news articles, forum discussions, how-tos, tutorials. It also learns millions of code snippets on the internet, academic papers, social media posts, and so on. After training, ChatGPT learns to recognize patterns in massive amounts of text. These patterns include how words relate to each other in a sentence, how grammar structures sentences, how context changes the meaning of words, and so on. There are numerous patterns in language. After training, ChatGPT has learned those patterns in these 175 billion parameters. It now can apply them to generate human-like text, just like our salary prediction model can predict a salary based on experience and education. ChatGPT can predict the next word in a sentence based on everything that came before. So, a large language model is just a next word predictor. I know it's hard to believe this, given ChatGPT's capability to generate remarkably coherent, insightful, and often human-like responses. But at its core, a large language model like ChatGPT is simply predicting the next word in a sentence based on patterns it has learned. It doesn't understand, reason, or think in the human sense. It keeps predicting the next word. So here is a simple example. Given an input like this, the quick brown fox jumps, and we call this a prompt, to ChatGPT, and ChatGPT will predict the next word based on this prompt. In this case, it predicts over. Then it incorporates that output word, over, as part of the input of the next prediction. And this time, it predicts the. This pattern keeps repeating until a stopping condition is reached, indicating that it finished generating all the text you need. All right, let's dive in a little bit and explain how ChatGPT predicts the next word. So in this case, given the input, the quick brown fox jumps over the lazy dog to catch a. So what is the next word given this input? Under the hood, ChatGPT computes a probability distribution over all the possible words in its dictionary. ChatGPT then samples from that distribution to generate the output word. In this example, the next word may be rabbit, chicken, fish. The word code may not be picked because it has a low probability. While playing with ChatGPT, you may have noticed that the model is not deterministic. If you ask it the exact same question twice, you will likely get two different answers. That's because the model samples from this distribution to generate the next word. So let's assume that in this case, ChatGPT picks rabbit as the next word. You may wonder why in this case the word code has a low probability. Because the phrase catch a code is pretty common on the internet, right? I'm pretty sure it is more common than catch a rabbit, catch a chicken, or catch a fish. Maybe. But why in this case the word code has such a low probability? It turns out that when computing this probability distribution, ChatGPT is using a mechanism called attention. The attention mechanism, which allows a large language model like ChatGPT to pay more attention to some inputs than others, regardless of where they show up in the input sentence. In this example, when ChatGPT is predicting the word after catch a, it pays a lot of attention to the word fox, then to the word like over, or the, or lazy, or dog, and so on, despite the fact that the word fox appears earlier in the input sentence. All right, in the end, ChatGPT produces a stop word, which is period. That stops this prediction cycle. So here's a quick summary. In machine learning, parameters are the building blocks They record the patterns a machine learned from the training dataset. And during training, the machine is learning relationships between data points. The power of ChatGPT comes from learning patterns on a massive scale and also its large number of parameters. If you found this video helpful, don't forget to give it a thumbs up. It really helps more students and researchers find this content. And if you want to keep learning about AI, ChatGPT, and how these tools can support your work, hit the subscribe button and turn on notifications so you don't miss the next video in this series. Thanks for watching.